to record your performance. That means whatever you are doing through a video camera. Okay, you got to record that and keep the recording with you, but you have to upload the hash of the recording. You have to upload the MD5 hash of the recording. The steps, at least on Linux, are clearly given here. So please follow these steps. If you are using Linux, you can follow these steps directly. I would of course recommend you to use Linux only, because okay, that is the first aspect. The second aspect is that we would prefer you to answer using Xzonal, the same software that at least I use for the lectures. Of course, other software may also be available. So to give you practice, we have also put up the first assignment. So if you click, so you should go to the students link and click on assignment. So I'm just opening it for, it's already open. So you can see it now also. So this is the first assignment. If you click on it, you find that you have a PDF. Okay, you can download this PDF and you can answer directly over here. So we left spaces here. So this is, you know, it's just to give you some practice for answering the class test. So I would recommend you to try answering at least 2 questions. So one involve so note that in Xzonal you can actually type. So you don't have to have a tablet or anything. You can actually type. That is the good thing about Xzonal. You can type your answers, and you can also put in LaTeX formula. Okay, so if the question requires using a LaTeX formula, you can also type in a LaTeX formula. So please practice doing that. The idea of giving you this assignment is so that you can practice. And note that using Xzonal, you can also type. You can also draw block diagrams quite easily. Okay, so Xzonal has features for drawing circles, boxes, and all that. So you can draw block diagrams quite easily. So, so here question 4. I think yeah. Question 4. I think you can, yeah, so you are asked to design a circuit. So I would recommend you to, you know, try answering question 4. So of course you can you can work out using a rough paper. I mean, when you're answering, and then you can just, I mean, you can type out the final version, and also you can make the drawings. Okay.
Hello, sir. But fine
Yeah.
if we do a handwritten copy of the same.
Sorry?
Is it okay if we do a handwritten copy of the same? Or is it necessary?
Handwritten copy you can do, will not stop you, but you might have problems. So I'll tell you what problems you can have. See, if you do it this way, the advantage is that your writing will be neat, first of all, and more important, the file size will be small, because handwritten matter will take up more, the size will be much bigger. All right. So when you upload over the internet, you might have problems. So will not stop you if you want to make a handwritten submission. Will not stop you, but hello. Yeah, but we have actually made provisions. For example, we have in the question
Sir, your
paper.
voice is disturbing.
Okay.
There is some parallel noise coming.
Can you hear me now? I don't know. Sometimes it gets. Is it?
Yes, sir.
Yeah. So in the question paper, we have also drawn some boxes where you can answer. So if you can take a printout, it is okay, but otherwise it is better if you can answer directly on this. I mean, if you have a tablet, then you can you can try writing using the tablet also if you have it. But I don't expect everyone to have a tablet. So this is the scheme that we are adopting. So please, practice a bit so that you don't have any
So
difficulty.
actually, if you have any other software with which you can write, that also it is okay to use. If you can use any other PDF editor or something on which using which you can write, it need not be external only. Any software that serves this purpose can be used.
Yeah. So that is what we wanted to tell you, and you will also notice that we have made groups for your theory, just as we have made groups for your lab, and those groups are displayed here. So in case anyone is left out or if there is any problem, you can. And very important is everyone should check that you are able to log in, because to submit your answer to the class test, you have to log into WBCM. So please ensure that all of you in the theory especially you can log in. If you have a login problem, so to log in you should click on students and then you should click on assignments. You will be asked, you will be prompted for, you will be asked to log in. So you should, and note that it shows course management student. So if it shows some other domain like so something else, don't try logging in there. It will not work for you. Your password will only work for course management student. Okay. So if you find that your login is not working, it is more likely that you are trying to log in to some other domain, which is not course management student. So just check that. So please check that your login is working, okay? And if you have a problem, let us know, then we'll reset your login, your password, all right? Okay,
Sir,
yes.
sir, I joined a few minutes late. Can you repeat that assignment thing?
Yeah, so this is the assignment.
Maybe we'll, okay, you can.
Yeah, assignment has already been put up, already been put up, so you can open the assignment after you log in. I'm just showing that assignment here, and what you want. So your class test is also this form. So you should practice answering this assignment because it's on Wednesday only, your class test. So just practice answering, in this style, using. If you are working on Linux, you can use external. If you are working on Windows, I don't know whether you have external there, but you can use any other suitable software also. The aim of doing this is to ensure that your PDF files are small. Those will be easier to upload, because when you are answering, when you are submitting over the internet, that is a significant problem. So yeah, so don't take that lightly. I mean, in the worst case,
Simant, you have. I think CRM, there are some questions. Simant, if you have any question, you can speak up.
Yes, sir. Actually, I tried doing the same thing, going to the student section and then assignments, but the domain name isn't the same for me.
No, it will, see, you will get this. You click on students and then you click on assignments. You will get this. This is what I got by clicking on assignments after clicking on students. You will get this. And do it for this course. That is the theory course, not the lab one. Lab one is a different course. So make sure.
Yes, sir. I did the same, but for some reason it's not working,
No, it
and
will
I'm
come.
not being
It has
able
to
to log
come.
in.
Just try again. You click on students, and from students you click on assignment. You will get this kind of. Or if you are already authenticated, you will just go through. That's all. All right.
Yeah.
CRM, some of the people have raised their hand. Those who have raised their hand can speak.
Okay.
So the theory groups are made to submit the assignment also in a group, or should we do it individually?
Yeah, so as I told you, on the first day, as you can see, we are given 5 questions. And in most of the groups, there are 5 people. So we expect everyone to answer one question. And of course, you should discuss among yourselves so that you know how each question is answered. So yeah, that is the idea. So you should, so it is expected that you will cooperate among yourselves and distribute the load evenly. Alright.
Also,
Sir, regarding the group assignment, sir, last day in the lab group assignment, the groups have been changed. So
Yeah,
the
some
ones who
changes
were,
we made. Yeah, let me tell you, we made some changes just to balance the groups because in one group we are having just 3 people. So for that reason, we had to shift one person from some other group to that group. We have made
yes,
minimal changes only. Yeah.
yeah. So like in my group, I guess the entire texture of the group changed. So like we did the assignment together, and
It's
uh,
all right. Yeah, we'll give you more assignments. It doesn't matter, and it's the same assignment. It's even the other group is doing the same assignment only, not a different assignment. So if you have done it together, there is nothing lost. Okay. Yeah. All right. Any other questions?
Sir, I have a problem in login. Actually, I changed the password, and for some
Yeah,
characters,
so
it is
that's
not.
what I'm telling everyone. If you see, I also asked you to set up a WhatsApp group. It is a bit difficult to check so many emails. So you please set up a. I think it's you can create a URL and just circulate among yourselves. You're quite just do that. So it will help. And if you have forgotten your password, just send me a message and I will reset your password. That's all. If you have forgotten, then there is nothing. But try to use a password that you will not forget. And as I told you, avoid some. Try to keep it. It should be non-trivial, but don't put too many special characters which may foul. So just ensure that your password works. Yeah. Anything else?
Sir,
Yes,
so
sir.
should I
Will exam.
message in Teams? Uh,
Yeah.
should I mail you or message in
Well,
Teams?
right now you mail me or message me either way, but do set up the group. Yeah, it is difficult to keep track of so many
Okay.
mails. Yeah. Okay.
Okay.
Yeah. Then next,
Sir, will exams be also conducted in this format? Means
until you
this.
come back, there is we don't have too many other options, do we?
No, sir. I was saying that do we have to edit the PDF
yes,
in the?
yes, it is. See, it is preferable to do it that way. Okay, it is preferable to do it that way, but if you fail under all conditions, you should inform us. We'll allow you other modes.
So because editing with a mouse will not be that good.
No, no, it will
Arita,
be when
you have
when
to
it,
answer mainly text. There is very little diagram, mainly in
yeah,
text.
and even when you have diagrams, Xzonal at least has the facility to draw block diagrams. You can draw block diagrams with a mouse quite easily. Freehand diagrams are not easy to draw with a mouse.
Worst case, what you can do is that you can use any other software to draw the diagram, save as an image and paste it here. You can use any software. It need not be external. You just use whatever software, Xfig or anything. You prepare as an image, and then you paste it in the. That can be done.
That can be done, but Xzonal has adequate facilities. We are
Has
not going to
adequate
ask you to
facilities.
draw anything
Exactly.
complicated.
So
So,
external
yeah,
is the best software for doing that.
yeah, Xzonal has the facility to, I'm just telling you, it has the facility to draw lines, draw circles, draw boxes. I think it can draw ellipses also. So that's all you require. I mean, yeah. Anything else? I think Professor Mitra will start.
Maybe CRM. Is there any library for the logic gates in external? For the
Sorry,
logic gates or blocks, we can
sorry,
project that.
sorry. Someone, there is a noise. Can you just mute it? Someone is, yeah. Poetry, you wanted to, you're saying something. Can you repeat?
So what I was saying is that maybe collectively you can prepare a library of diagrams for the gates and maybe the blocks.
No, gates are also, you can just write and. You don't have to, you can draw a box and write and. Okay, you can make it simple. We are not asking you to be very artistic also. Just you draw blocks. That's all. Blocks and lines. All right.
Sir, I want to ask,
Anything else?
yes, sir. I wanted to ask one thing. Sir,
Yeah,
in the team submissions, hello. Sir, in team submissions, like one of my teammate submitted my lab, the lab for the whole group, but the other, like I wasn't able to check that, like what was submitted.
See, I'm telling you, within the deadline, you can also download any file that has been submitted. You can always check it. If you want to change it, you can change it and upload. You just got to upload all the files together. That's all, as of now. So it's not, so within the deadline, you can do all this. It's not a problem.
Um,
Anything
okay,
else?
okay, and okay, let's see into it. And one more thing, that you're saying that we have to edit the same PDF that you'll be provided, right?
Yes.
So if like, can we add pages to that PDF? Like, if
If
I'm
you
not
if
able
you
to.
if you need to, you can, because Exona has the facility to add pages. You must have seen anyway. You can add pages. It's very easy. You just got to click, go to the next
Yeah,
page or
yeah,
something.
I understand. Like for the question one, you have assigned the whole page one,
Yeah.
right? So if I want to extend in page, so should I extend it between 1 and 2 question or at the end?
I mean, uh, you can
Because
put in the middle also. Normally, we'll be giving you enough space. So, I mean, if you look at this question one, you'll find that you need only one line or 2-3 lines to answer this. So, normally, you will not require. If absolutely you require, you can do something. It's all right. Yes, someone else was saying something.
Sir, is it possible that the date be shifted because a 2-day time for us won't be sufficient? Could it be
No,
kept next?
it is continuous evaluation. It is just what you have done in the class. All the lectures are also available. Slides are available. If you have followed the class, you can take the test now also. It is nothing. It is just continuous evaluation. That's all. We have not put in great challenges or anything. No.
And also see, it is an average over big number of tests. So you don't worry about individual test. I mean, the overall performance should be good.
Yeah. Okay. Anything else?
Sir, I had a question.
All right. I think Professor Mitra can take over. Yeah, please. Yeah.
Sir, if we wish to submit a handwritten answer sheet for the test, like, do we have to print out the question paper, or can we just use a?
No need. Don't. If possible, see, everybody will not have a printer in their home.
Yes, sir,
So,
exactly.
what you can do is that you can see, you use the PDF. You can paste whatever you want in. The best is to use the external. If you can use that, that is the best option.
Sir, I understand, but it might take time to get.
See, that's why we have given you this assignment so that you can have your setup. We have given you this assignment so that you can develop your setup today itself. And that is easy because we are doing it every day in every class. It's not difficult.
It's not difficult. We have been doing it.
Yeah.
Okay, you try. It's not very difficult, because if we can do it, you can do it much better. So you try. It's not very difficult.
Okay, sir.
Yeah.
So, but still, if we wish to submit a handwritten.
That is the fallback. You're focusing too much on the fallback. We have kept the provision for fallback. We are not stopping you, but
Yeah.
this will be much easier for you, for us also.
Okay, sir.
Okay, I think let us start with the
Yeah.
lecture. CRM, can you please
Hello, sir.
Yeah.
unshare?
I'm just saying. Yeah.
Hello, sir.
Yeah.
Sir, in my Miss WBCM, the passwords work for the or miss all the tasks, but not on submission.
No, you mail me. I'll reset your password.
No, sir.
Password is
Sir, I
required
reset the
only for.
password, but it's working, and I can log in another device also, but while submitting, it's getting
No,
issue.
it will work. It has to work. If it works for because then you are probably trying to submit from some other place. I told you submit that from students and assignments. If you click here, over there
Maybe
itself
CRM,
you
can
will
you share
find a
the screen?
submission link. Just use that submission link. Don't try to submit from anywhere else. It will work. It has worked for everyone so far.
No, sir.
Okay. Yeah.
Sir, I will send you reset my password.
Huh?
No, if your password is working, then don't ask him to reset.
If it is working, you are clicking the wrong link for submission.
Just
There is
check. If
another
it
link
is
for
working,
submission,
it
you
will
click on it.
work. And if you're having a problem with your password, we'll reset it.
Yes, sir.
Okay, let us start with today's topic.
Sir,
Yeah, please tell.
yesterday I have submitted the lab assignment in the WBCM, but it's not showing in the submission log. So I have mailed you the assignment of our group.
I don't know. Okay, we'll see to it. You have already mailed?
Yes, sir.
Okay, as such we are considering it, but we'll try to help you to make the submission.
Okay.
No, what is your name or roll number? Just tell me. I'll check it immediately.
Okay. Samanvita, 19 CS 10046.
Okay. So 10046. Yeah. It has not submitted actually. Submission is not there. All right. I will allow you to submit. Don't worry about that. For some reason your submission hasn't worked. I'll allow you to submit. Yeah.
Okay, sir. Thank you.
All right. Yeah.
Sir, just one more thing. I don't have like a webcam in my PC, so can I record from my mobile at
Yeah. No
almost the same
problem. No
speed?
problem.
And then,
No problem.
yeah. Yes, sir. Okay. Yeah.
But see, it is more important to you study and answer. That is more important. This it's okay. We'll allow for you understand all this.
So that is for proctoring. Just keep your setup because since we are doing it, just keep your setup so that you can record using your mobile. There is no problem if you record using your mobile. Yeah.
So I'll test it beforehand only if it's
Yeah.
working.
You test it beforehand.
Yeah.
Prepare your setup. That will be fine.
Okay, let us come back. Hey, you asked in the lab. You asked in the lab hour.
Okay, sir.
Let us go ahead with our topic today. Okay. All right. So yes. So let us start the class. So others may please mute themselves because there is some noise coming. We studied the binary coded decimal, that is the BCD code. So what we do is that, as you know very well by now, that every integer, every digit, every decimal digit from 0 to 9 is represented by its binary equivalent. And if you have multiple decimal digits, there are so you have 4 bits for one digit. So if you have n digits, you have 4n number of bits to represent a n digit decimal number into its BCD equivalent. So this is equivalent to saying that every digit of a decimal number is represented by its binary equivalent, for which the weight for every position of the bits are 8, 4, 2, and 1, starting from the MSB to LSB. So this is also sometimes called a natural BCD or a 8, 4, 2, 1 BCD. There are other possibilities. You may generalize yourself beyond this 8421 weightage to a general class of codes called weighted codes. So all these are as if we are representing a decimal number by a binary string. So if there are n decimal digits, there are 4n binary strings for the BCD case. So these strings, binary strings, in our language, we'll call them as codes. We'll call them as codes. So you can have a general class of weighted code where the decimal value for a particular binary string is nothing but sigma wi xi, where xi are the binary string at the value of the binary bit at the ith position, and wi is the weight of the ith position. So these are, for example, you see, these are the schemes. So you can have 2421 scheme, you can have 642 minus 3 scheme. So you can have your weights. In fact, what you can do, we'll see soon, that you can have non-weighted codes too. You can have non-weighted codes where there is the value of the corresponding decimal number is not sigma wixi, it is something else. It just weighting will not produce. You have to do more operations to get back that decimal number from the binary code, or more complex operations than simple coding, simple weighted sum. Okay, so now, yeah, others may please mute themselves. There is a lot of noise coming. Okay, now there are some, so this is a table of different weighted codes. Now there are some properties which we would desire of a, there are some nice properties we will desire of a code. Each of these properties are motivated by a number of applications, So one of the first property that you would be interested in is something called a self-complementing code. Self-complementing code, what it means is that if you take a decimal number and find its 9th complement. What is the 9th complement? In the decimal number, every digit you replace by 9 minus that digit. Okay, every digit you replace by 9 minus that digit. So if you have a 3-digit decimal number, it's basically the 9th complement of that number is 999 minus that number. And what self-complementing code means, that if you take such 9th complement pair of decimal numbers, their corresponding code words are binary complements of each other. That means you just flip the bits. Right? So you get their 9th complement in the decimal one. For example, see this BCD is not a 9th complement, because the 9th complement of 0 is 9, but they are not self-complement. The BCD for 0 is 0000, where the BCD for 9 is 1001. They are not complement of each other. They are not bit flipped versions of each other. Whereas you see this 2421 code, they are self-complementing. So let's check one. Let's say 2. The 9th complement of 2 is 7. So that 2421 code of 2 is 0010, whereas the 2421 code of 7 is 1101. So you see that's self-complement. They are self-complements. Right. So this self-complementation has some advantages. They are you can naturally, if you are taking the decimal 9's complement, and if you the flipping a bit is a very simple digital operation in terms of circuits, so you easily get the 9's complement. So that's the benefit. It can be easily proved that in any weighted code, if it is self-complementing, so self-complementing is a property we can achieve at least using weighted codes by properly choosing the weights. So if you it can be proved, actually I leave it as an exercise, that for any self-complementing codes, the sum of the weights has to be 9. The sum of the weights has to be 9. Okay, you check the second code and the third code in this table, they all sum to 9. Do they sum to 9? No, they don't sum. Yeah, they sum to 9. Both of them sum to 9. So both are self-complementing codes. So this can be easily proved. I leave it as an exercise. All you have to do is to just use the expression sigma wi xi and have the definition of complementation in nines complement and binary complement, and then you can see that sigma wi will always be 9. You can prove that. In fact, it is you can easily also check that there are only 4 self-complementing weighted codes whose weights are all positive, and there are only total 14 self-complementing weighted codes whose weights may also be negative. This can also be proved. You can check this. These are a little bit algebraic. So there are a lot of group theoretic explanations or interpretations of these facts, and many of the group theory people, they can easily prove these things. Okay, so now let us move beyond weighted codes. So weighted codes, they are good. You can easily get back the decimal number from the weighted code. No complex transformation is required to recover the value of n. But you can also get self-complementing codes, one of the design properties, by properly choosing the W. But there are some more properties we'll see which cannot be achieved using weighted code. You need more complex code, which are not just weighted but more complex. They are obtained by a complex method. So one of the main such codes we'll study is called a gray code. We'll study that in detail. There are other such codes also. Okay, so let us see some of the non-weighted codes. That non-weighted code means you cannot. So if you have a code word for a number, decimal number n, you cannot get back there does not exist a set of wi such that sigma wi xi equal to n. It does not exist. There are more complex operations that are required to construct the code words. I give here 3 examples of non-unweighted codes. These are so-called XS3 code, cyclic code, and gray code. Cyclic code is actually a more general category. I'll explain them. First, let me explain how these codes are obtained. Then I will talk about their properties. Okay, so XS3 code is very easy to get. What you do, you get the BCD code of a decimal number. For every digit, you get 4 bits. And to every digit, you add 3. That means you add 0011. You add 0011, which is 4-bit binary 3. You add that to every BCD code, you get the corresponding XS3 code. So you see 00000 is represented by 0011. 1001 is represented by 11. Okay, so you just add 3 to it. Note one thing, that some of the valid code words in XS3 are not actually valid code words in BCD because you are moving beyond 9. Okay, so naturally you can see that this is not a weighted code because I have taken a weighted code and I have shifted it. I have added 3 to every code word to get this. So that it's not a weighted code. So this XS code, I just like tell you a little bit why it was done. In the early days of the computer or communication systems, they were not very reliable. They would lose connection easily. When you are reading for your disks, the disks would fail. So this all 0 and all 1, these codes are not very preferred. All 0 means everything has gone dead, and all 1 is everything is high. So those code words, they may occur in some unnatural situation. So those code words, the 0000 is there in BCD, but that is avoided in XS3. That is avoided in XS3. Okay. There is a nice property of this XS3, that the property of that it is self-complementing. You can check that it is still there. 0 and 9, they are complements of each other. The self-complementing property is still there. There is one more property we'll now look into. This property is called the cyclic property, and that will motivate us to go into the next code. What is the cyclic property? Cyclic property says that between two code words which represent successive decimal numbers. So if you have code words for a decimal number I and I plus 1 or I and I minus 1, between the code words for two successive decimal numbers differ in only one bit. So 0 and 1, there is difference only in the last bit. And 1 and 2, there is difference only in the second bit. Similarly, you pick up any two consecutive words, they differ by just one bit. Their difference is only in one of the bits. Other bits are identical. So this distance between this can be more formally stated by something called an Hamming distance. So Hamming distance between two code words is the count of the number of bit positions in which these two code words differ. The number of bit positions in which these code words do not match. So for example, you see the Hamming distance between 0 and 9 is 1. The Hamming distance between 0 and 8 is 2. Okay, so what happens in cyclic code is that between between the codes of two consecutive decimal numbers, the Hamming distance is always 1. And this goes around as if in a cycle. That means the Hamming distance between 9 and 0 is again 1. It's circular. The Hamming distance between 9 and 0 is again 1. Right. So that's why it's sometimes called a cyclic code. Okay. Why this property you are looking for? That is between two successive decimal numbers, the Hamming distance is just 1, not more than that. Why this property you are looking for? Anybody any suggestion? Why this is a good property? Anybody any suggestion? Yeah.
To reduce errors.
During switching, it will take less time for changing one number to another.
Exactly. So both these are actually correct reasons. So let us come to the first reason, that it will reduce error. Say, for example, I have one of the bits have got corrupted. So you take any code word, say the code word 3, code word for 3. Suppose any one of the bits have got corrupted. Okay, so or let us look at the other way. So suppose look at as kind of an analog to digital conversion. So you are measuring something. Say you are measuring, say the speed of a car or speed of rotation of the wheel of a car or something. So if your measurement differs a little bit, for example, it instead of 3, you have measured it to be 4. Instead of 3, you have measured it to be 4. Your corresponding cyclic code will also differ a little bit, only one Hamming distance. Will differ by only one Hamming distance. So a small error in the decimal value will be a small Hamming distance change, delta, in the Hamming distance value in the binary, in the code. Okay, this is the important property. For example, it was not there in non-cyclic codes. For example, suppose between 0 and between 0 and 9, let's say just one bit has, if the distance is okay, well, not that. Let's say in any other case, suppose even a small change in the n value may lead to a change in larger number of bits. So that is not desirable. Well, the end I'll try to figure out how they handle the end. That means 0 and 9, they also differ by one Hamming bit. So how they are handled, I have to read up. I'll read. Maybe you can also read up yourself how that is handled. Okay, so this cyclicity is a nice property we'd like to have. Basically, small Hamming distance between two consecutive decimal numbers. So this gave rise to one code called a, and of course, well, we would still like to preserve the property of self-complementing and other things, because they will lead us to simpler circuits for doing arithmetic operations on this code. They will lead us to simpler circuits. Okay. So this is one of the things. By the way, one more thing I forgot to mention in the last class is that for the case of weighted code, it may be possible that there is a non-unique representation of some decimal digits. One particular decimal digit can be represented in two different ways or multiple different ways using the same set of weights. So they need not be unique. They need not be unique. So sometimes what is done, this weighted property is broken down so that if there are multiple representations of the same decimal, only by convention one of the representation is taken, others are used, other possible representations are considered as redundant code words and they are used for other purposes. Okay, forcefully the weighted property is broken down. You go to an unweighted code. Okay, so we have already seen two properties. We have seen the self-complementing properties. We have seen the cyclic properties. They have their advantages. Now we will construct one code which has both the cyclic and self-complementing properties, which is the gray code. Okay, I will explain it. What gray code means. Let me just use the pen. Okay, so there is so I need two properties. I need cyclic property and I need self-complementing property. Okay, let me study two other properties. One property is called extensibility property. Extensibility property and self-reflecting property. Okay, so first let me explain the self-reflecting property. Suppose I have a m-bit gray code. M-bit gray code. Okay, so I write down the m-bit gray code. I write in m-bit, using m-bit gray code, I write down all the 0 to 9, all the numbers for their m-bit gray code. And what I do, I as if do a mirror reflection. That means the first gray code comes to the last and the last gray code comes to the first. So I do a mirror reflection. Okay, so you do a self-reflection. Then to extend the m-bit gray code to a m+1 bit gray code, all I do in this mirror reflection, I append a 0 to the first set of 9 gray codes and 1 to the reflected set of 9 gray codes. Okay, so now we get m+1 bit, and this is the m+1 bit gray code for the these numbers. So you can extend it this. Okay, it's not just from 0 to 9, it can be others also. You can extend it. So this already you see, this gives you a rule. So you first start with a gray code 0 1, then you 0 1 you make 0 1, then 1 0 and append by 0 0 and 1 1. Again reflect that, append by 0 0 and 1 1. This way you can construct a m-bit gray code. I'll give a more easier way, more circuit friendly way of doing this. But this is the scheme. This is the scheme, and this actually you can check out. You can check this out easily. You see, it is 0 0 0 1 or you can see it this way. You see this is 0, 1 and then 1, 0 reflected. So the first four, you look at the last column, first four values 0, 1, 1, 0 reflected. Then I have appended it with 0, 0 and 1. So I get a 2-bit gray code. This again I reflect. So 0, 0, 0, 1, 1, 1, 1, 0, I reflect to get 1, 0, 1, 1, 0, 1, 0, 0. I append by 4 zeros and then 4 ones. This again I reflect, I append by 8 zeros and 8 ones. Okay, so this is you reflect, you append, you reflect, you append. You can extend the gray code to higher number of bits this way. Okay, so now let me give a more circuit friendly way of convert. So now I'll speak about how to convert a binary code, simple binary code, into a gray code, and a gray code back to a binary code. I'll get back to these equations, but let me first show you a diagram. How much time I have? 5 minutes. Okay. Okay. So let's say these are my binary numbers, B4, B3, B2, B1, B0. Okay, let's write it this way. These are my binary numbers. Let's put some value 1, 0, 1, 1, 1. And I want to get the corresponding gray code G4, G3, G2, G1, G0. So what I do, the leftmost binary bit, that is the most significant binary bit, I copy. Most significant binary bit I copy. Okay. So this is my first gray code bit as well. And then what I do an XOR between, so other GIs will be, so GI will be XOR of BI and BI plus 1. So first bit will be 1, second bit will be the G3 will be XOR of B3 and B4, which is 1. G2 will be XOR of B2 and B3, which is again 1. G1 will be XOR of B1 and B2, which is 0. And G0 will be XOR of B0 and B1, which is again 0. So this will be the gray code. So very simple rule. You just XOR them and get this. To get this, you XOR them to get this. XOR them to get this. Very simple. Very simple circuit wise also. All right. So how do you get the binary back from the gray code bit? It is the I'll first tell you another rule and then let me tell. So the first binary bit is same as the most significant binary bit is same as the gray code bit. For others, what you do is you check how many gray code bits to the left of that gray code bit are 1. So how many bits to the left are 1. If that number is even, so here you see to the left it is only 1, 1, which is odd. So if it is odd, the corresponding binary bit will be 0. And come to G3, to the left of it, to the most significant part of it, there are 2 1s, which is even. So B2 would be, for even it is 1, for odd it is 0, for B2 would be 1. Here there are 3. This is 1 here. So G3, this is G1. Okay, G1 there are 3. Am I making a mistake? I'm making a mistake. Wait, it is 3, so it should be 0. Let me check. But this, so this I'm telling as a rule, but this you can actually get back by just by using the XOR operation itself. Maybe I made some mistake here. Let me check it. But it can be easily derived. If it is wrong, I'll derive it again. Yes. So as I have told you that GI is BI XOR BI plus 1, and GN minus 1 is just BN minus 1. All right. So now how do I get back BI from the GI? You note here, I'll try to derive that. Note here that GI XOR BI plus 1, if you substitute
So you have muted yourself.
maybe I've overshoot the class time. Okay, let me try to get back that rule. So this is clear. So GI is BI XOR BI plus 1. So you, to get the ith gray code bit, you XOR the ith binary bit with the I plus 1th binary bit, and the last bit is a copy. So now how do I get back BI from GI? You can easily, I have already derived this. GI XOR BI plus 1 is BI itself. So to get BI, what I have to do, I have to look at the ith bit in the gray code and XOR it with the previous more significant binary bit, which is BI plus 1. Okay, so this I can recursively use because you know Bn minus 1 is Gn minus 1. So if I know Gn minus 1 and Gn minus 2 and Bn minus 1, I can get Bn minus 2 and so on. So if we move from left to right, the first bit is a copy, Gi to Bi. For the next bits, you take that binary bit, which you have already calculated, take the next gray code bit, XOR them to get the ith binary bit. So this, if you see, if you apply this rule, you take the corresponding binary number and look at the gray code, you see they will all match. They will all match. Okay, and again, it can be proved that if you just follow this scheme, all these properties of self-reflecting, self-complementing, cyclic thing, everything comes up by this construction. In fact, this can be shown. I don't have the diagram here. This can be wait. Let me see if I have the diagram. In the Kohabi book, I definitely have the diagram. So let me show you the diagram. Yes, this is the diagram. Yes, so the G5 and B5, they are copies of each other, right? And G4 is XOR of B5 and B4, and the other way around also. So to get B4, what you need to do is to XOR between B5 and G4. That is B4. B4 is XOR of B5 and G4, 1, 1, 0. B3 is XOR of B4 and G3, which is 0, 1, 1. B2 is XOR of B3 and G2, which is 1, 1, 0, 1. Okay, so this diagram actually converts between the two. So XOR is basically modulo 2 sum. So use that to convert between these two. Okay, let me quickly come back to just one more alternate code that will. Okay, so maybe I said in a little bit hurry. I should have explained with an example, but I think it's not very difficult. You can study it yourself also. So how do you get a gray code from a binary code, and how do you get a binary code from a gray code? And if you follow that, you will see all these properties follow. All the properties of self-complementation and other things will follow. Right. So this is the rule. You just need to remember this and this rule. Okay. All right. Now a few more things you can study. You can actually show that there exists. Does there exist a weighting scheme which can lead to the gray code or the XS3 code? Okay, can you do the weighting thing? In fact, what you can do is that for the XS3 you can actually show that no such scheme exists. And for each of these code representation, for example, XS3 and others, you can have a corresponding arithmetic operations, which are basically they do a simple binary addition, but do a correction or a compensation by a suitable 3 or 6 or whatever to correct the carries, for in the case of carry outs. Okay, now the most important property this XS code, this gray code and other things that will lead us to is something. Do I have time? Or maybe I'll do this in the next class. Is something called a error detection. That means in suppose any of the code, one of the bits are error. That means either due to communication or something, they are not the actual value that should have been. So there are two things we need to do. We'd like to detect whether at all there is an error not, calling an error detection. And then we can do an error correction. That means we find out which position in the bit string that is actually an error, so that we can flip that position, complement that position. Okay, maybe we'll do it in the next class. We need to discuss in more detail. So today's class, we have covered up to the gray code, We have studied how to convert binary to gray to binary. We have studied some properties of gray code. Intuitively, it will be easy that since Hamming distance between two gray code is 1, it is useful for it is less tolerant to errors. Okay, so in the next class we'll see error detecting code followed by error correcting codes. We'll see some modifications to these existing codes that we studied, so that this task can also be achieved. Okay, thank you.
So what will be the syllabus of Wednesday's test?
The syllabus